Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into an 11th grade topic. Why does discriminant work the way it does? Well, if you're new to my channel, I'll be putting time codes in for this video in the description box below. So use it to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what you said today or even on homework, you can always put it in the comment box below or visit my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 11th grade playlist in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video is only going to have one part, so leave a like, smash subscribe, and let's get started. In my previous video, we talked about the nature of roots, and we talked about how to find them using our discriminant. But I didn't really cover why the discriminant worked the way it did. So I want to take a little bit of time to do that today. Now, it may be very obvious for some, but it's not necessarily going to be obvious for everyone. So with a quick explanation for today, we should be able to bridge that gap for those who need it. Now, if you hadn't seen my previous video on the nature of roots, you can find it right up here. But in that video, we talked about where the discriminant comes from. Now we know that it comes from the quadratic formula. So let's assume we have this quadratic here, x squared plus 4x plus 4. Now, we can plug this directly into the discriminant, and if we were to do that, we would know that this has one real root. By plugging it into the discriminant, this tells us we have one real root. But if we didn't plug it into the discriminant, but plugged it into the quadratic formula itself, we would be able to find out exactly why it would have one real root. So let's do that. We know that our quadratic formula is going to be minus b plus or minus the square root of b squared minus 4ac all over 2a. So let's plug in our a, b, and c into this to figure out why does this give us only one real root. So here we have our a, b, and c plugged into our quadratic formula. And if we were to try to simplify this, we would have minus 4 plus or minus our square root of 16 minus 16 all over 2. Now you already see what's going to happen. This 16 and this 16 is going to cancel out, leaving us with a minus 4 plus or minus the square root of 0 all over 2. Now what's the square root of 0? That's going to be 0. So you really just are left with a negative 4 over 2. Notice you only have one root and it's real. Now, why did this happen? Well, notice that this 16 minus 16 canceled out. And by doing that, we no longer have anything to plus or minus to this real number on the outside. And notice that the thing that gave us a 0 underneath our radical was the discriminant. That means that the discriminant is going to be the most important part of the quadratic formula when determining the nature of your roots. And that's because it's going to determine, do you even have something to plus or minus? If it goes to 0, you have no hopes of having multiple roots because you have nothing here to plus or minus. But let's say it didn't go to 0. Let's say instead of having this quadratic, we had another one in which it went to a negative number. So some negative number here. Now this plus or minus means you're going to have two roots. So off the bat, because you have something here, you're going to have two roots. Now this is going to be a real number. Now if you look at that, you have a real number plus or minus something that's going to be a square root of negative number, right? What is the square root of negative number? Well, it's going to be an imaginary number. We know that the square root of a negative number is going to be an imaginary number when you simplify it. So it's some imaginary number. This is the form of, well, technically you have a 2 here, but that's not super important because you can always simplify it to be still a real number plus or minus an imaginary number, which is the form of a complex number, right? If it's plus, you have, well, some real number plus an imaginary number. If it's minus, you have some real number minus an imaginary number. Either way, you have a real component and an imaginary component, which gives you a complex number. And because you have plus or minus means you have 2. Hence why when your discriminant is less than 0, in this case, it gives you a negative number, you're going to have 2 roots, but they're going to be complex. That's why that works. Let's use our imagination one more time and assume that instead of having a negative number, we had an arbitrary positive number. So it wasn't negative and it wasn't 0. We had some positive number. Notice that this radical doesn't go away. And it's not negative. It's some maybe rational, maybe irrational, but it's always going to be real. Therefore, we know we have on the outside a real number, right? So in this case, it's going to be a -4 divided by this 2. Once again, it doesn't really matter because it's going to simplify to something that we know anyway. Plus or minus some real number. Well, if you have a real number plus another real number, or a real number minus another real number, you're going to be left with a real number. So we have 2 real roots, because there's no way you're going to get something that's not real when you combine 2 real numbers. So the discriminant, like I said previously, is going to be the most important part of the quadratic formula when determining the nature of roots, only because it's going to determine, do you even have something to plus or minus? If you don't have something to plus or minus, it's not going to give you more than 1 root. And if you do have something to plus or minus, well, depending on if you have a negative under it or a positive under it, you're going to have either a complex number at the result or a real number as a result. Well, I hope you were able to follow in today's video, and hope you understand that it is never a bad thing to ask why something works. And if you had that question and this answered that question, then I'm really happy. However, if you had any questions about what you saw today, or even on homework, remember you can put it in the comment box below, or visit my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, remember to leave that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found the video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I really hope this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney. Here's your playlist, and this has been another session of Tutor Me Sempai.